Meet Mittens. To most people, she is just a fluffy ginger cat who enjoys sunbeams and yarn. But in the world of quantum physics, Mittens is about to become an icon. She is the center of a thought experiment that has boggled minds for nearly a century. This is the story of Schrödinger's cat, the most famous feline in history. In 1935, Austrian physicist Erwin Schrödinger wasn't looking for a pet. He was looking for a way to show how truly bizarre quantum mechanics really was. He dreamt up a scenario that sounds less like physics and more like a villain's plot in a sci-fi thriller. A sealed box, a cat, and a deadly secret. Inside this box, he placed a device containing a tiny bit of radioactive substance. So small that in 1 hour, there's a 50-50 chance one atom might decay. If the atom decays, the Geiger counter triggers a hammer. The hammer breaks a flask of poison and, well, Mittens doesn't make.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
Here's the catch. Until you open the lid and look inside, you don't know if that atom has decayed or not. So, what is the cat's status? According to the Copenhagen interpretation of quantum mechanics, the atom exists in a state of superposition. It is both decayed and not decayed. By extension, if the cat's fate is linked to that atom, then the cat is mathematically both dead and alive at the same time. It's a quantum coin flip that hasn't landed. Now, here's the kicker. Schrödinger didn't actually believe this was happening. He was using it to show how ridiculous quantum rules look when applied to big things. Quantum mechanics works perfectly for the tiny building blocks of our universe, like electrons and photons. They can be in two places at once. But when he scaled it up to a living, breathing creature, it feels wrong. It feels impossible. And that was exactly Schrödinger's point. Think about the double-slit experiment. When we don't watch, electrons act like waves, passing through two gaps simultaneously. But the moment we observe them, the moment we look, they suddenly pick a path. The act of looking changes the outcome. But some scientists didn't think it was ridiculous. They proposed the many worlds interpretation. Instead of the cat being dead and alive, the universe itself splits. In one reality, you find a living cat. In another, you find a less happy result. You are just seeing one branch. This leads us to quantum entanglement, what Einstein called spooky action at a distance. Things can be linked across the universe. If our cat is entangled with the atom, their fates are woven together into a single quantum state. They're part of the same mysterious fabric. It gets even weirder. There is an extension called Wigner's friend. Imagine a scientist in a lab observing the cat. They know the result. But for a friend standing outside the lab, that scientist is also in superposition until they ask for the result. Reality becomes a chain of observers. This brings us back to Wavefunction Collapse. The moment the lid is lifted, the maybe turns into a definitely. Nature is forced to choose. And most of the time, in our world, we find a grumpy cat who just wanted to take a nap in peace. But that doesn't mean the dead state wasn't real. This isn't just theory. We use superposition to build quantum computers, machines that can solve problems in seconds that would take years for us. Normal computers use bits that are either 0 or 1. Quantum computers use qubits, which are both 0 and 1 at the same time, just like our cat. Today, scientists at institutions like MIT are even putting tiny mechanical drums into superposition, vibrating and still at the exact same time. We are slowly learning that the weirdness Schrödinger was making fun of might actually be the fundamental truth of our reality. So, the cat isn't just a zombie or a riddle, it's a metaphor for the mystery that keeps physicists awake at night. The universe is more flexible than we think. It leads back to that ancient question. If a tree falls in a forest and no one is there to observe it, does it even make a sound? Or does it even fall? What do you think? Is the cat real, or is the math just a tool? Let us know your theories in the comments below. We love hearing your quantum ideas. Thanks for joining us in the weird world of SciCurious. Until next time, keep observing, because you might just change the world.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.